Chris Chinnock here for Display Central. I'm at the Showstoppers. It is, what is it, Tuesday? Tuesday night at the CES 2014. I'm here with Andy Davis, DisplayLink, where actually you've got two very important innovations that I wasn't aware of that you're doing. And I think it's really important that we tell our viewers here some of the stuff that you're doing. Let's start with the 4K displays and the ability to use USB to DisplayPort through your new graphics chip. Tell us about that chip and what it can do.
Sure, no problem at all. So what we're actually showing here at the show is our latest innovation. This is the new DL5000 chipset. What we're showing here is actually the DL5500. This is the first chipset in the 5000 family, which we're announcing here at CES. We're one day into the show, and we're already an innovation award with this, which we're pretty chuffed about. That's pretty exciting. The exciting thing here is what we've done is we've built a technology that enables us to effectively have a graphics driver on the host notebook, and then come out to a chipset which can reside in an adapter over a single USB cable, enabling us to connect up to 4K. Right. Now, what's really difficult here, of course, is 4K. The resolutions of that, if you do the math, is huge. The bandwidth capabilities required for that are enormous. And we're actually capable of driving that over a single USB connection. Now, what that means is that you no longer have to worry about what connectors have I got on the notebook, right, because every notebook has USB. And the beautiful part of this is even if you go down to having a tablet, and the tablet, for instance, may only be able to render up to 1080p. You know, if we look at like the latest Dell notebooks and the Dell tablets, the Venue 8, 1080p, beautiful tablet, ultra portable, 8-inch. We can actually take that, and with our graphics driver, which is effectively seen by the operating system as a graphics card, we can output and drive up to 4K. So we can take 4K content from that tablet and now drive a full 4K display.
That's amazing. Even though the graphics card on the tablet only supports 1080, you can do. And now, can you do 30 frames or 60 frames?
So today we're 30 frames.
Okay.
What's the special?
Okay. Well, no. So this is extremely powerful. At least I think, in my opinion, because now you have the ability to have really a secondary graphics card in an outboard dongle, right, essentially. Exactly. That uses some of the processing power of the onboard GPU, but it's it's almost an alternative software layer or firmware layer, correct?
Right, exactly. It really simplifies things because we're not, we utilize some of the power there, yeah, but really we're utilizing processor power. Now, the key here is that if you actually analyze what the processor does, for almost 90% of its time, it's idle. So in actual fact, there's a lot of horsepower there that can be utilized. And what we've done with the technology is we've actually made it completely dynamically adjustable. So what that means is that if you're just looking at, let's say, PowerPoint content or email, actually nothing is changing on the screen.
Right.
And that's very important because what we'll do from our ASIC is we'll render that screen locally from the ASIC. So the bandwidth across the USB bus is completely empty. Now that means also to the processor, loading is zero. So when you're not actually doing anything, which happens quite a lot actually, you wouldn't realize it, but it happens quite a lot. You'll be taking a phone call or you'll be talking to colleagues or working up some ideas, it's down to zero. Yeah. The loading only then picks up when you actually start to interact with the device. And then we do that in a flexible way such that, if you were to plug in a hard disk drive behind, we'd monitor that link, yeah, be aware of that link, and we dynamically adjust our compression capabilities on the fly, usually within around 1 frame. So typically to the naked eye, you'll never even see that. How we compress is based on a proprietary architecture so that we don't stay with the standard compression algorithms. We've done that to ensure that we get the crispest of text, the smoothest of video, the lowest of latency, the highest levels of interactivity. And to us, these are no compromise areas. Yeah. And we build all of that over a standard USB connection.
And folks, this is actually another second very powerful technology that you have here, a uniquely developed compression technology. Is there a name for this?
So we call it currently the version is the DL3. Okay. DL's DisplayLink, and this is the 3. Okay. It's kind of the DL3 Plus because we continue to evolve this and take it forwards. Okay. And the business model we have actually, when we work with the Lenovo's, the Sonys, the Toshibas, the HPs, the Dells of the world, obviously they're integrating our chipsets into their solutions. Yeah. But we're providing software as well. We continually rev that software and update that software, and that's freely available as updates from our website. So this is not something that we charge after for, but this is a benefit, an ongoing benefit, if you will. So, when Windows 8.1 came out, it's a free update. You just naturally have that. If you want to move to an Apple environment, you're just going to get that naturally. You know, we're also demonstrating here at the show Android and Chrome OS. Now these are just snapshots of the future, but these are areas that, you know, naturally we could look at rolling out to industry partners. And the best business model that suits that, we've still got to explore, but we're already starting to look at making inroads into those markets as well.
Yeah, and you mentioned there's another chipset, a 3000 something or other, that you're using to create essentially a USB hub but with a graphics adapter built in, which is kind of creating a new market opportunity for some of the laptop and computer makers. But you know, when we were talking before we started the camera rolling here, I also mentioned the fact that in the broadcast environment, adaptive bitrate streaming requires that service providers create sometimes a dozen or more versions of a particular video file, all at different bit rates, so we can adapt and switch to those different files. If you can now take basically one file and dynamically adjust the compression, that's a huge market opportunity in the broadcast market that right now you're not even looking at.
We're not today. We're not today. We're very focused today on business and enterprise. Yeah. You know, the technology has so many areas it could be deployed in, but we're still a small company. Yeah. So today we're staying very, very focused on business and enterprise. The docking market to us to date has been the largest market, and you're quite right, the 3000 series and predominantly the 3900, which is a dual head graphics chip, USB graphics chip, which not only integrates graphics, but we've also integrated gigabit Ethernet and 5.1 audio into the device. So effectively you're getting a docking chip, you know, a docking station on a chip, if you will.
It's a graphics card and a docking station, 2 in 1.
Precisely. And the beauty of that is that not only are, you know, you're getting the flexibility to now have just USB to connect all your docking stations, you also have the ability to look at, regardless of what kind of platform it is, it'll just work. Right. So from a CIO perspective, from an IT perspective, you're effectively future-proofed.
Yeah, because USB is going to be around for a long time.
It's not going away.
Cool. Thank you very much.
Chris, thank you so much.
All right. Chris Chinnock here for Display Central.